All right, welcome back, kiddies. It's our fourth and final unit that we're going to be going over. This is Trig Identities, and let's just get into it. Let's start with trig proofs. When you're proving, remember, there's two things you have to remember. One, you have to only work on one side. So let's split this into one side. Let's go right here. We're going to split it down the middle. And two, we got to put everything in terms of sine and cosine. So if you look at this guy, we could put tan in terms of sine and cosine by saying it's sine x over cosine x, okay? And if we remember, cosecant is equal to 1 over sine x. All right, that's step one. We did a good job with that. Now the second thing to do is, since this is two fractions, we're going to flip and multiply. So we're going to do sine x over cosine x times sine x over 1. When you multiply these two together, we get sine squared x over cosine x. And if we look at these, they're equal, so we say that they're equal to each other, and we have done our proof. Check. All right, we got that done. Let's keep moving. Number 2, this is the sum and differences formula. Remember, you don't have to memorize any of this. It's given to you on the regions. The formulas are there for you. All you have to do is know how to apply them. So let's do this guy right here. We're going to find the exact value for the cosine of 105. The way to do this is to split the cosine into two different numbers. So the cosine of 105 is equal to the cosine of 60 plus the cosine of 45. How did I know that? Well, you just test out some numbers and you see which one gets you there. All right? Got it. So this is going to be our A. So we're going to say A is 60 and our B is 45. Now going back, now we just have to plug in. This is addition, so we're going to use our addition formula, which is right here. So this is going to be the same as the cosine of A plus B, or 60 plus 45, okay, is equal to cosine of 60, which is our A, okay, that's our A, plus the cosine of 45. See, I'm changing my colors here. Looks nice, right? Oh, sorry, times. That's times. All right, cosine A times cosine B, and we're going to subtract sine A, so sine 60 times sine 45. All right. Now, at this point, I'm sure we have these all memorized, so we could just put these in. So this is going to be the cosine of 60 is 1/2. Whoop, 1/2. And we know the cosine of 45 is square root 2 over 2. We're going to subtract that from the sine of 60, which is square root 3 over 2, times the sine of 45, which is square root 2 over 2. All right? When we multiply these two together, we get square root 2 over 4 minus, this times this is square root 6 over 4. And since we have the same denominator, we could just rewrite this as square root 2 minus square root 6 all over 4. And that would be our final answer. Boom, bang, bing, bong. Okay? That's how you do that. You could do this one on your own, figure out the two numbers that make 165. Could be addition, could be subtraction, all up to you. This second one, cosine, cosine. Now, what this actually is, what is equivalent to this? Okay? Well, it's basically asking you, what is A? So our A over here is 40, right? And our B over here is 10. Now, if we look at this, what it's really asking you is, which one of these formulas do we need? And it's the same as this formula, cosine, cosine plus sine, sine, all right? And it's cosine A minus B, all right? So we can actually just say that this is equal to the cosine of 40 minus 10, right? Because that's the same formula. So this is going to be equal to the cosine of 30 degrees. Since we know the cosine of 30 degrees, we could just say that the cosine of 30 is equal to square root 3 over 2, and that is your answer. Once again, we just plug these into the formula. We have A and B. A is 40, B is 10, all right? Since this is the subtraction formula, the difference formula, this is the same as the cosine of A minus B, which is just cosine 30, and the cosine of 30 is square root 3 over 2. I know we didn't go over those in class, but that's just how it's done. Finally, the third one. All right, the sine of a plus b. We know the sine of a is, okay, we know the sine of a is 5 over 13, and the cosine of b is 4 over 15. We're looking for the sine of a plus b, okay, of a plus b. What we got to do is write down the formula, okay? So let's check it out. Up here, this is our formula, sine a cosine b plus cosine a sine b. Oh. So it's sine a cosine b plus cosine a sine b. All right? Okay, so from here we're just going to, that's the eraser. From here we're just going to plug in what we know. So let's try that out. So we know that the sine of a is 5 over 13. And we know the cosine of b, we do know that one, is 4 over 5. Now we don't know the cosine of a, and we don't know the sine of b. All right? So guess what? Yeah, we have to figure those out. Well, if you remember, the way to do that is we just draw two triangles. We're going to call this triangle A, and we're going to call this triangle B. Okay? So in triangle A, we know that the sine is 5 over 13, so that's opposite over adjacent. And we know in B, we know our adjacent is 4, our cosine is so adjacent over our hypotenuse is 4 over 5. So we got to find our missing sides. So for this one, this is just a 5, 12, 13 triangle, so that's 12. And for this one, it's a 3, 4, 5 triangle. Now you could use the Pythagorean theorem, but we know these, so I'm just filling them in for you. So for this one, since we know we need the cosine of A, we could say the cosine of A is equal to the adjacent, which is 12, over the opposite, which is 13. The hypotenuse. For this one, we need the sine of B. So the sine of B is equal to the opposite, which is 3 over 5. So we just plug these in now. So we get 5 over 13 plus times 4 over 5 plus 12 over 13 times 3 times 5. This gives us 20 over 65 plus 36 over 65. And our grand total will be 56 over 65. And that's just how that's done. All right, let's do double and half. All right, double. So if we're doing the double of this one, so we know the sine of A is 3 over 5. We want to find the cosine of 2A. Well, this is really just plugging into this formula. So like I said in class, if you see the cosine of 2A, what are you going to do? Just look for the formula and plug in. It's that simple. So we're going to put in the cosine of 2A, all right, is equal to, well, the cosine 2A squared. So we don't know that, so it's the cosine 2A, all right, minus the sine squared A. Now we do know what the sine A is, so we could just put 3 over 5 squared. Now once again, we need the cosine to figure this out, so we're going to draw a little triangle. Okay? We know that in A, our opposite is 3, our hypotenuse is 5, and we know this triangle well by now, so this is just 4. So cosine A is just equal to adjacent over hypotenuse. All right, so the cosine of 2A is going to be equal to 4 over 5 squared minus 3 over 5 squared. The cosine of 2A is therefore equal. We square this, we get 16 over 25 minus 9 over 25, and that just gives us 7 over 25. And that's just how it's done. Now, like I said, it really is just about plugging into a formula. If you know the sine, you plug it in. If you know the cosine, you plug it in, and you find all your missing values. It's just about plugging into the formula. That's why they're really not so bad. The same thing goes for this one, okay? If I know the cosine of theta is 1/8, and I want to find the positive value of the sine of 1/2 of the angle, I just use my half angle formula, okay? And it's just a matter of plugging in. So I know the formula is the sine of A over 2, or half of the angle, is equal to the positive or negative, but I'm just looking for the positive, 1 minus the cosine of that angle, so it's 1 minus 1/8, over 2. Well, what we do from here, it would just rewrite this one. 1 minus 1/8, well, I'm going to turn that into 8 over 8 minus 1 over 8 over 2, and that's going to give me the square root of 7 over 8 over 2. All right, let's keep going. Another way to say this, when we divide by 2, so it's 7 over 8 times 1 over 2. We just flip the bottom. Remember, this is the same thing as 2 over 1. And this gives us the square root of 7 over 16. Can that be simplified? Yes, Emily, I know you were going to say something. Just follow me over here for 1 second. This can be rewritten as the square root of 17 over the square root of 16, right? The square root of 7 we don't know, so we just leave that as the square root of 7. The square root of 16 is 4, and that is your final answer. Yes, it was long, but you just have to follow the steps, and you will be fine. Last 2 problems. For this one, remember, we're just going to treat these like these are x's. And if it's easier for you, let's just solve this like these were x's. These are our variables, okay? So you could just write this as 5x plus 3 equals 2x plus 4, all right? And just for now, just so we know it, we're just going to say x is the sine of x, okay? Just keep that as a note. Well, we know how to solve this one, so we're going to subtract subtract 2x from both sides, subtract 2x, and we get 3x plus 3, that's gone, equals 4. All right? From here, we subtract 3, and we get 3x is equal to 1. And from here, we just divide by 3, and we get x is equal to 1/3. Now, we're not done because x is not x. Remember, it's sine of x. So we'd say the sine of x is equal to 1/3. Now, since we're looking for the angle, what do? That's right, the inverse. So we do the sine -1 of 1/3 is equal to, and we just put that in the calculator. Oh, let's try to do that. And that just gives us 19.47 degrees. All right, so we just solved for that one. All right, last one, guys. Once again, I'm just going to say, let's change these into x's, okay? So we're just going to say, whatever, x equals the sine of x. For now, right? We're just going to replace it. So this is 2x squared, because don't forget this squared right here, minus 5x minus 3 equals 0. All right? From here, you know how to solve. This is a special quadratic factoring one. So we're going to go like this, make a little x, and we've got to say 2 times -3 is -6, and -5. Our two numbers, well, that's right, it's -6 times 1. So we split, so it's 2x squared minus 6x minus x minus 3. We factor by grouping now. Group, 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 group. From here, we're going to factor out a 2x, x minus 3. From here, we could factor out a -1, x plus 3. Oh, sorry, that was supposed to be, oh, that's +1, my bad. So we just factor out a 1. And so we get 2x plus 1 and x plus minus 3. All right. Sorry. All right, from here, remember, we just have to replace what we know. We replace the x's with the signs. So this is going to be 2 sine x plus 1 equals 0. That's one solution. And sine x minus 3 equals 0. I just did change these into my signs of x's. All right, the time is about to end on this, so I'm just going to quickly note what to do. You solve for this, you get sine x equals -1/2 x, -1/2, and you get sine of x equals 3. You do the inverse on your calculators, you find out what you get. So we find out that x equals something, you figure that out. And for this one, remember, x can't be the sine can't be more than 1, so this is impossible.